Lesson 10 for radical equations. Our objective today is to solve radical equations and checking for something called extraneous solutions when solving radical equations. Everything we've done so far was radical expressions. There were no equal signs involved, and now today we change it up. Equal signs are involved, and every time that happens, you're looking for a value of a variable. That's what it's all about. Okay, in order to solve any radical equation, you must get the radical sign by itself on one side of the equal sign. It must be by itself. And then to undo a radical sign, you square it, but then you would square both sides. Okay? And then proceed to solve for the variable. So here's what's going to happen. I'm going to show you some very basic problems. Example A is radical x minus 3 plus 8 is outside the radical equals 15. Okay, so if you go by what is up there with an asterisk, you must get the radical by itself. So that plus 8 should not be there. So that just means I'm going to subtract 8 from both sides of the equation. And when you do that, you get radical x minus 3 equals 7. And that's great. That's good. Get the radical by itself. To undo the radical, you square both sides. When I square the right, I just simply get 49. But when I square the left, the square root and squaring are complete inverse operations, complete opposites. They cancel each other away. So you get x minus 3. To solve that equation, you add 3, and therefore x is 52. And you are done.
I like this. This is kind of like some of the other stuff we've done.
Yep. All right. Example B. Radical x plus 4 plus 6 equals 14. Okay, again, we want the radical by itself. So subtract 6. And you get radical x plus 4 equals 8. You square both sides. 8 squared is just going to be your regular old 64. On the left, when you square something in a radical sign, it just removes both those things and you just bring x plus 4 out. You subtract 4 and x equals 60. Questions about that? All right. The next one, radical x plus 2, the square root of x plus 2 equals negative 8. Any thoughts on that? Yep. Nope. Yep. Nope. Can the square root of anything right now equal a negative anything?
No.
For us, no. So anytime the radical equals just a negative like that, you're going to say empty set. So for all practical purposes for us right now, it can't equal a negative. You will learn a lot more about this topic at a later time, but right now for us, you just say no solution. All right. Questions about any of those? Jared. All right. Now, extraneous solutions. Doesn't that even sound painful? Extraneous. Anyway, extraneous solutions. You have to check your solutions to make sure they are true. And this happens when there is a variable on both sides of the equal sign. And basically, you're looking to make sure it does not give us any negative value that should not be. That's what you're looking for. So you see these two examples, how there is a y on both sides. So that's going to cause a little bit of an issue with as far as extraneous solutions are concerned. Okay, so on example D, we already have a square root by itself. So I'm going to square both sides. Okay, now on the left, radical 2 minus y squared. Remember, the squaring and the radical cancel each other out. I'm going to say 2 minus y. On the right, well, y squared is just y squared. Who can tell me what kind of equation I'm going to end up with here? It'd be, huh?
You have to square root both sides.
Nope. No, we wouldn't want to square root both sides. That's going to get us right back where we were. What? Quadratic. Anytime you have a squared term, it is a quadratic equation, and you want one side to equal 0. So what I'm going to do, since my y squared is positive on the right, you go with that. You add y so that it gets taken over, and you subtract 2 so that it gets taken over, so that this side is 0 and this side is y squared plus y minus 2. We have many options to solve that quadratic. The last resort is always using quadratic formula, negative b plus or minus b squared, plus or minus square root of b squared minus 4ac over 2a. That's the last resort. Your first option should always be what we did first, and that is factoring. So you bring down 2 sets of parentheses. What gives you y squared? Y and y. The minus in front of the 2 tells you the signs are going to be different. A factor pair of 2 whose difference is 1. 2 and 1. I look that it's a plus y, so 2 goes with the plus and 1 goes with the minus. You test outer inner. Outer's negative 1, inner's positive 2, and yep, it gives me 1. You set each one of these equal to 0. And I'm going to get 2 answers. So I go negative 2, y is negative 2, y is positive 1. You can't stop there. You must go back up here in the original problem and test your answers and see if they would work. So here's what I mean. You would go to this. You would say the square root of 2 minus negative 2, and that it equals negative 2. I'm checking y equals negative 2. Well, on the right, this would be the square root of 4 equals negative 2. What is the square root of 4? 2. And it can't just be negative 2, so you would throw this answer out. It is called an extraneous solution. You have to test the 1. So you would say radical 2 minus 1, is it equal to 1? And radical 2 minus 1 would be square root of 1. And what is the square root of 1?
1.
So this would be a correct answer. Josh.
Would there ever be a time that neither answer would work?
Could be. And then you'd say what?
And just say,
Yeah. All right, any questions about that? So you have to test them when there's a variable on both sides of the equal sign. What?
So you just put the number that you got,
Back into the very original problem.
and then you try to get,
See if it is true.
and it'll equal 0 if it's true.
No, it will equal whatever it equals. So like it says that the square root of 2 minus y equals y. So the square root of 1 equals 1. Yep, that's true. You're testing that the value of the left equals the value of the right. Do it. Okay. So example E, y equals radical 2y plus 3. So I've got the radical by itself. So I'm going to square both sides. And I would get y squared equals 2y plus 3 because the squaring gets rid of the radical. I notice that it's going to be a quadratic because I have a y squared, which means I'm going to subtract 2y from both sides, and I'm also going to subtract 3. So my equation would be y squared minus 2y minus 3 equals 0. Parentheses, because you always try factoring first before you do anything else. Y and y, the minus in front of the 3 means the signs are different. Factor pair of 3, whose difference is 2, so it'd be 3 and 1. Since there's a minus in front of this 2, 3 goes over here. So y plus 1y minus 3 equals 0. You set each one of those equal to 0. Whoops, and you solve them both. So y is either equal to -1 or y is equal to 3. It could be both or 1 or whatever. So you have to test it. So I'm going to check y is -1 first. And that would mean -1 equals the square root of 2 times -1 plus 3. -1 equals the square root of 1, and that one would be wrong because it can't just be a negative, so that means that would be wrong. You can kind of tell if it's a negative and there's only a y there by itself, you're going to throw it out. Now if there's something else there with the y, then you need to test it. Okay, then we're going to check y equals 3. So 3 equals radical 2 times 3 plus 3, which would be 6 plus 3. Okay, what's the square root of 9?
3.
So that one is a good answer. Your answer is y equals 3. All right, so we have radical r plus 3 equals r minus 3. So since the radical is by itself on the left, we're ready to square both sides. Okay, so when you square both sides, the left just becomes r plus 3. But the right, you have to imagine it as r minus 3 times r minus 3, or squaring a binomial, which is square the first term, r squared, multiply the 2 and double it, minus 6r, and square the last term, plus 9. Again, it's a quadratic, so we need to take everything to the right. So I'm subtracting r, and I'm subtracting 3. So 0 equals r squared minus 7r plus 6. You try factoring r and r. The plus in front of the 6 means the signs are the same. They're both minus. Factor pair of 6 that adds up to 7, so 6 and 1. R minus 6 equals 0, and r minus 1 equals 0. Add 6. So r equals 6. Add 1. R equals 1. I need to test. So if I test the r equals 6 first, radical 6 plus 3 equals 6 minus 3. So radical 9, what is that? So that's a good answer. Test the 1. Radical 1 plus 3 equals 1 minus 3. What's radical 4? 2 does not equal -2, so that is a bad answer. That is extraneous. So r equals 6 would be the only answer that you would give.